Well, hi everyone. Got this practice test. I think it's more for the um, just the answer key than for any other reason. But what I am going to do is I'm going to work. You do not have to use the same steps or anything that I do on this. So I just want you to, and methods and everything, especially like right here, when I say method of your choice, we got substitution, we got elimination, and we have graphing. You can do graphing if you want. I don't know that we'll get many of those, but that is an option. All right, but I do say let's use substitution. So I'm going to take the first equation, x plus y equals 6. I'm going to subtract x from both sides. And I have y equals 6 minus x. All right, so I'm taking this y and this y I'm going to replace with 6 minus x. So I have 3x minus 2 times 6 minus x equals negative 2. And that's 3x minus 12 plus 2x equals negative 2. 3x and 2x make 5x. And I still have this minus 12 equals negative 2. I'm going to add 12 to both sides and have 5x equals 10. I'll divide by 5. I get x equals 2. And then y is equal to 6 minus 2, so y is equal to 4. All right, so it's always a good idea to check your work. 2 plus 4 is 6. 3 times 2 is 6. 2 times 4 is 8. 6 minus 8 is negative 2, so I feel good about that. Now, we can use elimination. I could multiply this one by 2 and this one by negative 4 or something. But what I'm noticing here is we already have opposites. So I'm just going to add those two equations together just the way they're standing. 6x negative 3y plus positive 3y is 0. Negative 22 and 16 is negative 6. And I get x is negative 1. And I'm going to plug it into the second equation. 2 times negative 1 plus 3y equals 16. Negative 2 plus 3y equals 16. Let's add 2 to both sides. 3y equals 18. And y equals 6. All right, so negative 4 minus 18 is negative 22. Negative 2 plus 18 is 16. I like the answer here. All right, method of your choice. You do not have to graph. If you want to graph, it's here. It's not a requirement. So I think I'm going to use elimination because I have a choice. You can use substitution if you'd like. Although you'd have to deal with fractions or decimals if you did use substitution, so I may not recommend that. So I am going to multiply this equation by 2. I'm going for the x's here. And that gives me 4x minus 6y equals 24. I get negative 4x plus 6y equals 36. That cancels too. So I have 0 equals 60. And that is false. And whatever you get, you may, if you chose a different method or different kind of a multiplying or something, you may get something different, but you're going to get something false. Okay, that's no solution. And if we were to draw the graph over here, we'd get parallel lines. And we're looking for that point of intersection, and parallel lines do not intersect. Alrighty. Method of our choice. I think I'm going to use elimination again on this. 3a plus 5b equals negative 27. I'm going to, I think the most efficient way on this, and you don't have to do the most efficient way, I'm going to do what I think is, and cancel out the b's. And I only have to multiply this top equation by negative 2. Negative 6a minus 10b equals 54. Alright, and this one is 4a plus 10b. I already have a negative 10b and a positive 10b, so we're good there. Negative 46, so I'm looking at negative 2a equals 8. Dividing by negative 2, I've got a equals negative 4. And I'll put that in the first equation. 3 times negative 4 plus 5 times b equals negative 27. Negative 12 plus 5b equals negative 27. I'm going to add 12. I have 5b equals negative 15. Divide by 5, and I got b is equal to negative 3. Okay. Oh, I just did that. I didn't check yet, though. Negative 12 plus negative 15 is negative 27. Negative 16 plus negative 30 is negative 46. It checks. Okay, this is the graph and shade problem here. And I think I have another just to practice. Y is greater than or equal to 2x plus 3. So my boundary line is y equals 2x plus 3, and that's in slope-intercept form. I'm going to do a solid boundary line for that one. And here's 3. Slope is 2 over 1, up 2 over 1. Now, I want to be as precise as I can, because the point of intersection is the I'm just looking for a straight edge, guys. The point of intersection. There's an old card here. All right. So I want to draw this pretty accurately. Whoop. Okay, get it right in this place. All right. Now, this is y equals 1/3. Y is less than 1/3 x plus 5. So I'm going to graph, shading. I didn't do the shading. Okay. Let's do the shading first. I'm going to use 0, 0 for a test point. And 0 is greater than or equal to 2 times 0 plus 3. 0 is greater than or equal to 3. 0 greater, 3 false. Okay, you see 0, 0 is this side of the line. That's the false side. The true side is this side of the line. So I'm going to lightly shade that side of the line. Alright, now I'm doing this one. Y equals 1/3 x plus 5. And I'm going to use a dotted line for that. 5 to 5 is right here. I'm going to go up 1 over 1, 2, 3. Do that a couple of times, and then down 1 and left 3. Okay, I'm going to draw my dotted line right along here. Okay, now I'm going to use, it's this line, here's 0, 0. Just kind of ignore this shading right now. Just think about this line. I'm going to shade if it's true, this side for 0, 0, and this side if it's false. So 0 is less than 1/3 times 0 plus 5. 0 is less than 5. 0 is less than 5. That is true. That's going to lead me to shade toward the 0, 0 point, this side right here. Okay, the part that got shaded twice is right here. So that is the part that where the solutions, the ordered pairs that are solutions to both inequalities lie. Alright, so these both had boundary lines that were easy in slope-intercept form. Okay, this one, I'm going to, for the 3x plus 4y is less than or equal to 12, my boundary line is 3x plus 4y equals 12. And I'm going to make the intercept chart here. Put 0 here, 0 here. This is 4y equals 12. So y is 3. Put a 0 here. I have 3x equals 12. So x is 4. Okay, I'm going to use a solid boundary line. And 0, 3 is here. 4, 0 is here. I'm going to draw a solid boundary line here. Okay, I'm going to use a test point of 0, 0. And 3 times 0 plus 4 times 0 is less than or equal to 12. 0 plus 0 is less than or equal to 12, which is true. So I'm going to lightly shade this side of the line. Alright. 6x minus 3y is greater than or equal to 18. And boundary line is 6x minus 3y equals 18. And doing this again, when x is 0, negative 3y equals 18. Divide by negative 3, you get y is negative 6. Okay, when y is 0, you got 6x equals 18. Divide by 6, and I get x equals 3. So 0, negative 6. 1, 2, 3, 4, 5, 6. And 3, 0. 1, 2, 3, 0. This boundary line is solid also. This point and this point. Drawing my solid boundary line. Okay, now test point, 0, 0 is not on it, so I'm going to use 0, 0. Is 6 times 0 minus 3 times 0 greater than or equal to 18? Is 0 greater than or equal to 18? The answer is no. That is false. Okay, the false side is this side of the line. The true side is this side of the line. So let's shade the true side of the line and heavy shade the parts that got hit twice. This is the fun part. All right. Last problem, a 3x3 system to solve. Okay, you guys have anything you want to do. Eliminate x's, y's, or z's. So I would encourage you just to do this before you watch what I do. And then let's just see if we get the same thing at the end. But there's lots of avenues to go. I think I'm going to go for the y's. I'm going to try to eliminate y's. And the first thing I'm going to do is the first equation. And the second equation. -2. And I'm going to multiply, I'm trying to eliminate the y's. I'm going to multiply this equation by 2. Gives me 4x minus 2y plus 6z equals 16. Yes, 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 and do not forget that. All right, and x plus 2y, looky there, minus 2z equals -2. 4x and 1x is 5x. The y's are canceling. 6z and -2z is 4z. 16 and -2 is 14. All right, there is one. 5x plus 4z equals 14. I'm eliminating y's. I'm going to use the first and third equations. So 2x minus y plus 3z equals 8. 4x plus 3y minus z equals 4. Okay, I'm going to multiply this equation by 3. I'm going to leave this one alone. And I have 6x minus 3y plus 9z equals 24. This one stays, so 4x plus 3y minus z equals 4. 10x, canceled y's, plus 8z equals 28. Okay. Five x plus 4z equals 14. 10x plus 8z equals 28. Uh-oh. All right. Now, I'm going to multiply this by -2. I got -10x minus 8z equals -28. I've got 10x plus 8z equals 28. And that cancels. That cancels. So I got 0 equals 0, which is true. Okay, guys, when you get to this point, you get 0 equals 0, and that's always true, we're just going to go ahead and so what happens is these represent planes. They're meeting at a line, and if it's true, it's this line that they're meeting at. So we're going to go infinite solutions when this happens. All right. You guys take care, and I will see ya.